Hey everybody, Mrs. Johnson here. Hey, one of my favorite sections that we're talking about today, solving nonlinear systems. So think about what we've been doing in class for the past week. We've done substitution, we've done elimination, we've done this weird stuff called Gauss-Jordan. And every time we solve one of those equations, we get an ordered pair. That means the spot where the two lines come together. I'm going to give you a second to kind of copy these down because now we're doing nonlinear systems. What that means is stuff that isn't a line. Okay, so I have a couple different examples. There are lots of examples up here, but the first one I want you to look at is a parabola and a line. Look at when you intersect a parabola and a line. Do you see how it creates two intersection points? That means when we solve that kind of a problem, we are going to have two answers. What about two parabolas? Two parabolas, when you put them together like so, they create, again, two intersection points. That means that we're going to have two answers for that one. What if you do something really weird, like intersect a circle and a parabola? Look how many intersection points there are. There's 1, 2, 3, 4 of them. 4 intersection points, that means we're going to have 4 answers. So just as a heads up, these are not your normal substitution and elimination problems, but they're going to have x squareds and stuff in them like this one. This is a normal line that you're used to seeing, but now what do we do with an x squared? So again, keep in mind that you're going to have more than one solution, most likely, when you're having a nonlinear system, so not just y equals mx plus b stuff. Here's some tips for you right here. You're going to use substitution when you can easily get an x or a y by itself. Like in this problem, you can easily get an x or a y by itself by just moving stuff over. You're going to do elimination when you can easily cancel something. It's like, look at my y's right here. We could cancel those right away if I add the two lines together, and that's the process I'm going to use for example 1. Again, you are going to have more than one solution, so just be ready for that. I'll talk about that when we get to it. And the last thing is, keep in mind, the stuff that kind of sucks about these problems is that there are a lot of different ways to do them and still get the same answer. So I referred to example 1 when I was talking about substitution and elimination. So that's just because you can do the problem a completely different way from someone sitting next to you and still get the right answer. Let's go right into number 1. The very first thing that I noticed first about example 1 is that if I do normal elimination right away and I add my two rows together, that means that my y's will cancel out right away. So that's a super easy way to just look at this problem and start it. Yes, you could do substitution and do other things. Let's go with the elimination because I noticed that first and I think you probably noticed that first too. Here's the weird thing is that how do you combine x squared and x? You can't. What you're supposed to do is write x squared plus x. They're not like terms. So to add them, you just add them. Okay? And then now we have to also add the 2 and the 0. So we get 2 over here. And so something strange about this is that, okay, I think I know how to solve a quadratic. Yes, this is called a quadratic because there's an x squared in it. Let's bring everything over to one side so that I get 0 on the other. So that's going to be x squared plus x minus 2. That means it factors. X plus 2, x minus 1. That means I have two answers. X equals negative 2, x equals 1. Now be careful because it's tempting to think the answer is negative 2 comma 1. We have two answers here. Think about what kind of a line this is. This is just a line, y equals mx plus b. This is a parabola. So this kind of is going to look like this example that we have here. We're going to have two answers, and right now all I found is the two x values for the solutions. So what I'm going to do is write my solutions over here. Since I have two different x values, that means I'm going to have two different ordered pairs. Negative 2 comma something, also 1 comma something. And that's by using this negative 2 and this negative 1. I'm going to have two ordered pairs. So now here's your tip. Use the easy equation to plug back in. Use the equation to plug back in. So many people will choose the most difficult equation to plug back into. Doesn't this one look a little bit easier than this one just because it doesn't have an x squared in it? So let's use that one. Yeah, you can do it the other way, but it's so much harder and there's a lot more room for error. So I'm going to do when x equals negative 2. I'm going to do that one first. So I'm just going to use this equation and I'm going to plug in the negative 2 for x. I get negative 2 minus y equals 0. This means that y equals negative 2. Sweet. So when x equals -2, I now know the y value. I have to do the same thing for when x equals 1. So I'm going to do that one, and then I'm going to be finished. It's just confusing because there's like a lot of plugging in. So when x equals 1. I'm going to use the same equation, this one. But instead of -2, I'm plugging in 1 now. So I get 1 minus y equals 0. This means 1 equals y. So I have an answer of 1. So here, you guys, are my solutions for the very first problem. So what would be really cool right now is if you check Desmos, or I guess your graphing calculator, and what you're going to find in Desmos when you graph both of these two examples is you're going to get a parabola and you're going to get a line. And the two intersection points that you're going to get are, I bet you know what they are. One of them is -2, -2, and this one is 1, 1. Okay, so that is what we're looking for, and you can kind of check these in your graphing calculator or on Desmos just in case you're curious. All right, so that is kind of a new thing. We get 2 different answers for this, which is pretty cool. It's really exciting. Let's do number 2. So something interesting about this one is that, do you see how if I add these together, I can't cancel? If I add these together, I can't cancel. This is not a good elimination problem. So let's do substitution. I can easily get either x or y by itself. I'm going to try and get y by itself. You could also do the same thing by getting x by itself and plugging it in. But what I'm going to do with this now, I'm just going to do a normal substitution. I'm plugging it in for y. So that's going to give me x squared plus something squared equals 9. I'm plugging into the top equation, and into that top equation I'm plugging in -x plus 3. So just be careful when you're foiling this because of the negative sign. It makes it a little bit trickier. But that's going to give you -x times -x is x squared. -3x and -3x makes -6x. Careful with the negatives. And then 3 and 3 makes 9. And so I'm just trying to solve this thing again. 9's cancel, so I get 2x squared minus 6x equals 0. This has a GCF. And this is going to give me 2 different answers. I get x equals 0 and x equals 3. Okay, so keep in mind the answer is not 0, 3. It's not 3, 0. I'm going to write them over here. Solution. One of my answers is 0, something. Another one is 3, something. So what I'm going to do is I'm going to choose the easiest equation. This equation looks easiest to me. You could also use this one. Even though like you moved the x over, this is the same equation as this. So maybe I'll use this one. So I'm going to do when x equals 0, and I'm going to use this equation, this one, to plug it back in. I get y equals -0 plus 3. That means y equals 3. That's what happens when x equals 0. So you have to keep track of like, okay, I'm doing 0 right now. That's this one. I got an answer of 3, so I'm putting it here with the 0. And then we're going to do the same thing for when x equals 3. So that means I'm going to get y equals -3 plus 3. So y equals 0. So when I plugged in 3, I got 0. So those are my 2 solutions for this one. Let's talk about why we have 2 solutions for this one. I'm not sure if you know this. This is a y equals mx plus b line. It's a negative slope, and it starts at 3, so it's a line that goes down. This, we've talked about it very briefly. This is a circle. And so if you want to type that into Desmos real quick just to see what it looks like, this is a circle and a line. So yes, what we're going to have here is 2 different intersection points. And that's why we have 2. Okay? Let's do number 3. So let's see, number 3. Again, I don't think that there would be an easy way to get one of the x's or the y's by itself, but hopefully what you're noticing is if I add these 2 rows together right away, then these y's are going to cancel. And so that's nice. That's a really quick, simple way to do elimination. Even though it's not a normal x and normal y, they're x squareds and y squareds. So what I'm going to do is add these together. These are like terms. So x squared plus 2x squared is 3x squared. And when I do 10 and 17, that gives me 27. This means that x squared equals 9. And this means that x equals, be careful, plus or minus 3. So again, I have my solutions here. I have positive 3, and I have negative 3. Okay, and in this case, again, remember when we're plugging in, we're supposed to choose the easiest equation. This one looks a little bit easier to me than this one, just because this one has a negative and a 2. So I'll probably use this one, but you could get the same answer if you use the other one. Just make it easy on yourself. So I'm going to do when x equals 3 first, and I'm going to use this top equation here. So I'm going to plug in 3 squared plus y squared equals 10. So that's 9 plus y squared, which means y squared equals 1, which means y equals plus or minus 1. Okay, this is weird. I got 2 answers when I plugged in 3. Okay, let's see what happens when I do negative 3. So I'm going to plug in over here. When x equals negative 3. So I'm going to still use the same equation. Negative 3 squared plus y squared equals 10. Well, that's still 9 plus y squared. So when I plugged in negative 3, I got plus or minus 1. Okay, this is weird. So I guess let me write out the fact that I have 4 solutions here. I have 3 comma 1, 3 comma negative 1, negative 3 comma 1, and negative 3 comma negative 1. This is really strange. Notice how we have 4 solutions here. I would definitely recommend typing these 2 examples into Desmos, because I think you know that this is a circle, but what's weird about this one is, what does this shape even look like? The fact that it's a minus sign makes it not a circle, and the fact that this has a 2 in front of it makes it not a circle. Okay, so here's something really strange, and we're going to have an entire chapter on graphs that look like this, but the top equation is a circle, like I said. The bottom equation is 2 sideways parabolas, but they go together. So it almost looks like a baseball or a basketball, which is really weird. These are sideways parabolas. This is actually our last chapter of the year. But this, you guys, is why we have 4 solutions for this one. So it's really different to make sure that you don't forget those plus or minuses. It's really important. Okay, let's do this very last one. Excuse me. This one is also kind of a strange example, but so I can't add or subtract anything together right away because this is really weird, but we have this XY situation. So what I'm going to do is isolate one of those variables, either get x by itself or y by itself. So I'm going to get the y by itself by dividing both sides by x. Okay, so I have y equals 6 over x. And what I'm going to do is I'm going to plug in the 6 over x to the y. You've probably never done a substitution like that before, but this is how to substitute. You just get one variable by itself. Usually we add and subtract to do that. In this case, we're dividing. So my new equation that I'm plugging into the top is going to look a little bit strange. Instead of y, I'm putting 6 over x. Okay, this is weird. I'm going to square both of these things because that's how you square a fraction. So that gives me x squared plus 4, 36 over x squared equals 25. And so from here, what I'm going to do is clear the fractions. I'm going to multiply everything here by x squared in order to clear the fraction. So x squared times x squared is x to the 4th. This is getting ridiculous. And when I do this x squared times this x squared, the x squareds cancel, and I just have 4 times 36, which is 144. And then when I do the 25 times x squared, I have 25x squared. Still kind of strange, which is why I wanted to finish with a weird problem like this. Let's set it equal to 0. Oops, that's going to give me minus 25x squared plus 144. And this actually does factor. Remember how since it starts with x to the 4th and the middle term is x squared, you can factor them both into x squared and x squared. And actually 2 factors of 144 that add up to 25 are 16 and 9. Okay, so let's do that. We are almost finished. This means x squared equals 16, or you can factor it into x minus 4, x plus 4. This means that x equals plus or minus 4. This part you can factor into x minus 3, x plus 3, or you could just square root both of them and you get x equals plus or minus 3. Wow, so I have 4 solutions for this one. So I'm going to set up all 4 of them and get them ready to go. I have positive 3 something, negative 3 something, positive 4 something, negative 4 something. And yes, those are all of my x values, so that's why I'm plugging them in for the x's. So now all I have to do is choose the easiest equation to plug into. And I think what I will do is use the original equation here, xy equals 6. And I'm going to plug in when x equals 3. That means that 3y equals 6. That means that y equals 2. And what about when x equals, keep in mind I'm just using this normal equation here. This one is way harder to plug into, so I'm going to use this one. When I plug in negative 3 for x, that makes negative 3y equals 6. That means y is negative 2. When I plug in 4 for x, that means 4y equals 6, which means y equals 6 over 4, which is 3 over 2. And last but not least, plug in negative 4. That means negative 4y equals 6. That means that y equals negative 3 over 2. So these are my 4 solutions with all the work shown. And these are really crazy graphs and stuff. Type them into Desmo, see what they look like. But it's just normal substitution and elimination. It's just in a little bit of a different way. So we're going to work on these in class tomorrow, you guys. Bring your questions. Thanks for watching. Have an awesome night.